This is an application which I had, so I think all of you know this building and you know the people who are there, so the lovely people and such a very nice people and always working on very interesting topics here. This is the SCPK telemedicine building here. So, and this is Dr. Saroj Mishra who is working here and is doing a telemedicine session with international participants who are located in places like Afghanistan, Africa, and other locations. This is Dr. Ghoshal himself doing a session with, I think, Mednipur Medical College. And these are all on the website, which I actually found and I placed it there on this slide. So what I did is that I had the very nice opportunity of working with Dr. Saroj Mishra and his very good team of people who are there. And what we had done is that we had got access to some, and this is again another slide about telesurgery in practice, and that is getting broadcasted for education purposes to remotely located hospitals. So what I was talking about is that I had the very rare opportunity of working with such a good team where telemedicine is one very used technique to actually reach out to the to remote locations for education purpose and also for facilitating in consulting as well. So so this is again another photograph about where I think education is being imparted to doctors located at a remote location. So now you must be wondering, so what is the connection of artificial intelligence here? So what I could do is that I had picked up the schedule. So the daily schedule that this medical college or the super specialty hospital SGPGI follows with the other centers to where it actually does this telemedicine with. So they are spread across the country, northern part of the country, eastern part of the country, southern part of the country, and also I think some in the western part of the country. Now, some of them are academic institutes, and some of them are hospitals or medical institutes on their own. They may be having academic activities happening, or they are just taking care of patients there. So that is what is where these telemedicine sessions were being broadcasted to at that point in time when I was doing this study. So, and then we found that there are also collaborations that SGPGI has with foreign countries, where also like Afghanistan and Africa and other locations also telemedicine sessions are held regularly from SGPGI Lucknow. I think even with Raebareli and other locations also it was happening regularly. So what we had done is that we had picked up the schedule of the sessions that were happening. So on a given day, how many sessions were happening and what type of that session was it? So was it a general session? Was it a tele-CGI session, or was it a follow-up session? What was happening? So we had picked that up from the data or the schedule that was being used by the center to broadcast to the various location. And we also had found out that from the schedule that the various departments like clinical immunology, transfusion medicine, endocrine surgery, pathology, all of them, I think around 7 or 8 of these departments, radiology, were doing broadcast or were doing this telemedicine sessions to the remotely located centers or like medical institutes across the country. So what we wanted to do, again, this is also one of those sessions in progress, I think, yes. And these are all the rooms at Lucknow, your Lucknow Center, and you can see Dr. Saroj Mishra also here, so with his team. So what we had tried to do was nothing great, but a very interesting thing that what I wanted to learn is that since you've got this data with you and you have got these sessions which are happening, and the sessions are happening to remote locations, so can we actually get a model to learn the pattern in which these sessions are happening, right? So as I was mentioning, KS is actually the place from where the sessions are getting originated. So it could be an admin session, it could be a pathology session, it could be a clinical immunology session, it could be an endocrine surgery department doing a session, it could be the nursing department doing a session, and it could be the transfusion medicine department doing a session. Now, these sessions are again very interesting in nature. Some of them are follow-up sessions. So again, as we all understand, telemedicine aims to actually cut down the distance between the patient and the doctor, and also tries to ensure that the patient does not need to come back regularly to the doctor and can be taken care of from the remote location where they are located. So as we understood here, that some sessions were done specifically by endocrinology department and others to actually take care of the patients post their surgery that they had undergone at the Lucknow Multi-Speciality Center of SGPGI. So that was those follow-up sessions. Then we had tele-CGR sessions, and we had some sessions which were general in nature. So we actually try to understand or summarize the data in terms of how these sessions were happening. And as I was telling you, that these sessions were happening to academic institutes or non-academic practicing medical institutes. And where were they located? They were located either in India or abroad. So what we were trying to do is that we were trying to learn from this data whether there is some pattern or by which we could actually figure out that what is going on, and can we automate this entire process of scheduling. I understand it's a very basic scheduling process and it can be done manually, and domain experts are required to do it, because you as doctors would be having much more insight in terms of which location needs what type of telemedicine session to be beamed at it. But we thought that once we have, and we can sit with the domain experts and find out why those sessions were happening, but can we also automate the process, and can we also, given, say for example, if I'm given a record set and I'm told that this is the particular department and this is the particular session and this is aimed at this academic institute, so can I tell it that where should this session go to, so that it is optimal and we don't have a situation where it is wrongly going to a place where there is no requirement. And it would also help in optimizing the resources, because as we understand, all of you doctors are very busy, and if we can have a model which can actually ensure that this time utilization of doctors is optimized, then that can be the best case situation that we could have. And all these telemedicine sessions can be correctly designed and scheduled so that there is no chance of any of them going wrong. And uh, and there is the basic objective, that is to ensure that the patient gets the healthcare delivery is done correctly and to the best possible fashion, and even the remotest of the remote villager or the citizen of the country gets to benefit out of it. So what is the methodology that we had followed? We had tried to, as Dr. Ghoshal was telling us, that first take a training set of data and then train the algorithm with that training set of data. So what type of algorithm were we using? We were actually using actually classification algorithm. So we wanted to classify the telemedicine session into whether it should go to a national location or to an international location. So that's what we are trying to do. So there are very standard algorithms like Navid algorithm, bagging tree, CUT, or decision tree. So these are very standard algorithms which are there and which can actually give you a tree or an algorithm or a set of steps that you should follow so that the data can be understood by the machine very easily. So we just tried to apply that technique onto this data set that we had got from SGPGI and try to see whether we could get the machine to actually learn these patterns. And given an unknown situation or a test set, as Sir was also just mentioning a few minutes back, can we actually can the machine correctly tell us that whether it should be beamed to a national location or to an international location? So what was the data like? So the data we picked up was around 5-6 years of data that we could pick up, and here we had so we had two models that we created. One is for the national and one is for the international, and we tried to see whether they were doing, which of them was doing better than the other. So we had got around 500 data points for the international sessions that were being held by SGPGI, and around 2,000 data points for national sessions which were being held by SGPGI. And we found out there are 6 departments at SGPGI who were very prominently involved in this telemedicine activity. And as I was telling you, that there are three types of sessions that they do, mostly general, tele-CGR, and follow-up. and remote locations are either academic or non-academic, and that's how we were looking at this data set. And the remote location can be again international or national. So let us look at the results of the, or if I just say something which has. Okay, so before we get into the algorithm, so we just quickly look at the data that we had. So if I just draw a frequency chart of the data that we have here, and it is very easy to understand. So what we find out is that there are two regions where in international location where the telemedicine sessions were getting aimed at or were being broadcasted to or being carried out. And if we look at this data set, we find that in case of region 1, the clinical immunology and the endocrinology surgery clinical immunology, this is the clinical immunology department, and then we have the nursing department here and the transfusion department here. So they were carrying out some general sessions and some CGR sessions. That's what they were doing, right? So this is what they are doing. So mostly the general sessions are predominant in nature, and whereas they also have some tele-CGR sessions being conducted by these department, clinical surgery and endocrinology surgery and transfusion medicine. And if you look at region 2, we find mostly all of them are doing general sessions with these international units or locations that are there. So this is from, if you just summarize the data, it is this which comes out from the data straight away. Now, if you look at the national scenario, it is very interesting. What we find here is that the follow-up sessions are mostly done for endocrinology surgery, and that is what we found out on discussion with the experts there, that people come to Lucknow, do the surgery and go back, and it is preferred that they should not come back very frequently to Lucknow, because anyway, that the basic objective is to ensure that the patient delivery of care happens from a remote location and not to come back and forth to Lucknow. So here you can see almost 124 sessions are being carried out, which are to follow up in nature. So that is how it goes. And if you look at region 3, so this is, I think, region 1 is eastern part of the country. And if you look at region 3, where we can find some interesting thing, that we find a combination of tele-CGR and general sessions getting conducted mostly. And if you look at so, and if you look at pathology, clinical immunology, and endocrinology surgery, they are doing the combination of tele-CGR and general session. And in case of region 1, very interestingly, lots and lots of follow-up sessions getting conducted. So that is the data that we have. Now, if I again look at the data, I'm just trying to visualize the data so that we understand what is the context that we're talking about. So the data we had was, as you saw, 2000 for national and 500 for international. So we're just trying to see and understand and perceive that what is going on in the data, so that we can understand whether the machine is learning it correctly or wrongly. So if you look at this data here also, you can very clearly see that in region 1, this is the beige color one or the light color one that you see here. This one is predominant, and you can find that in region 1, administrative activities are most, then clinical comes second, then nursing and endocrinology comes third, and so on and so forth. Right? So you can actually look at the breakup. If you look at, if I take department wise, so how are the departments actually focusing their sessions to? So if you look at endocrinology per se here, that is this block, the fourth column here. So you can see that 300 of the sessions are being addressed to in region 1, that is eastern part of the country, and 149 into region 2, and then the remaining are to region 3 and international. So you can clearly see what's going on. If you look at pathology, then you can clearly see again pathology is also having a significant amount of sessions being directed to region 1 in India, right? So, and admin sessions are most in case of international ones, and also so that's how it goes. So we can clearly see a breakup of the sessions which have happened, the type of the sessions, and how the activities at SGPGI was getting conducted. So this is raw data. This is what human being is understanding. So can we make the machine to understand this and help us in automating the entire process? So now let us look at this diagram. The slide is a bit crowded, but I think all of us can understand it. Is very simple. So this is a decision tree or a classification, a decision tree which is getting created, or a rule, a set of rule is getting created out of the data so that the machine can understand this data and interpret what we as human beings were interpreting from this diagram on the other side, right? So we were interpreting this by ourselves here. So if the machine had to, so this is what we were interpreting ourselves. So we want the machine to interpret the same thing automatically from the training data. So let's see whether we are making sense or not. Okay, so what happens here is that, as I told you, that there are 6 departments, and that is 1, 2, 1, 2, 3, 4, 5, 6 departments are there. And these 6 departments are trying to broadcast or trying to do a telemedicine session to international locations, which are 2 in number. Right, so that is the basic objective, and there are 3 types of sessions that can happen. So now, if I look at this thing, that is, if the department is pathology and endocrinology surgery, so let's look at this. So if it is pathology means number 2, and endocrinology means 4. So if you look at this here, it is saying that if it is 2 or 4, then you follow this path, right? So if it is pathology or endocrinology, then what is happening here is that this is pathology and this is endocrinology surgery. So if it is pathology or endocrinology surgery, then most of the sessions are either of type 1 or type 3. So what is type 1? One is general, and type 3 is tele-CGR, right? So let us see what is going on here. So if you look at this diagram here, so you find that if it is of 2 and 4, that is of pathology and endocrinology, and then if it is of type 1, that is of general, then it would be either endocrinology surgery and pathology departments in region 1, where this or let me put it this way, that endocrinology surgery and pathology department will be broadcasting to N2 region, right? So let us go and check here, N2 region, right? So pathology is 16 here. Let's see. So yeah, so IN1. So let's check here. So pathology is 2 here. Okay, so this is, yeah, in region 1. In region 1, so pathology is 3, right? So this is what we are talking about. So this one is actually tallying with this one, right? So this is the data that is tallying here. And similarly, we're talking about region 2. And if you talk about pathology, so there are 16 out of this 30, which is showing up here. So actually, the computer or the system is being able to think like a human being and is actually learning like a human being, and that is getting picked up by from the training set, and this learning is actually happening, right? Similarly, if you look at the other arm here, so I think we have understood this. So what I'm trying to talk about here is that just like Dr. Ghoshal showed us that he could predict who is going to die and who is not going to die, here also we could actually figure out, or we can make the machine learn, just like we are learning ourselves the data. The machine can also learn the data and can actually create some rules, and that rules actually tally with what we are seeing in the data itself, right? That's what we are trying to do here. Similarly, if you're talking about department pathology and endocrinosurgery, and if it is general, right? So if it is general, this one, then it belongs to IN region 2. So we can clearly see that the machine is actually learning it correctly, right? So it is understanding that if it is this department and if it is this type of session which is happening, then where it is aimed to, it is understanding it, right? And it is learning it. If it does that correctly, then our job is mostly done. Then similarly, if I come to this block, here what it is learning is that if you look at this number 3 here, it is learning the next thing, that is, if it is of administrative and nursing nature, so administrative and nursing, then it is going to be broadcasted toward region 1, right? So administrative is this one, and so 213, you can see this number here. So that means it is learning it correctly. And if it is nursing, then it's also going to be here. So 26, it is 26 here. Right? So it is learning it correctly from the data. Right? So similarly, I have just listed down all the rules here. So if we talk about if it is transfusion medicine, and if it is TR is equal to 0, that means it is not going to a region where it is a non-academic institute where it is going. So right. So if I go along this arm, so transfusion medicine is equal to the department where it is originating, and it is going to a medical college, which is or to a location where it is non-academic in nature. So it is going to end region 1, right? So again, this would tally with this data that we have. So let's look at transfusion medicine. So it is here. So and it is going to end region 1, right? So it is actually tallying. So the machine is actually learning the data, and so that is the first step of it, that from the training set, the machine should be able to learn the data. Now, if we come to the next, okay. Now, as our Dr. Ghoshal was also talking about, how do you know that this is not overfitting? How do you know that it is learning correctly? How do you know that it is not mugging up the data? So for that, you have to again split it up into training set and testing set, and also do a validation out of it. Right? So here we broke this data into training set and testing set, and we tried to check whether it is doing correctly or wrongly. So what we found out is that since there were two regions, N1 and N2, so we found out that here 25 regions it was doing correctly, it was finding out correctly, and 6 regions it was finding wrongly. The total was 31, 6 was going wrong, and in this case, so this is true and being pointed out as true, and this is also true, and this is also getting predicted as true, and this too is where the problem was. So in this case, there were 3 things which were going wrong, or 3 centers which were going wrong, and there were 6 centers which were going wrong here, right? So in this case, we had an accuracy of around 90%. In this case, we had a accuracy of 73%, and the overall accuracy is 82%, right? So there is room for improvement because the algorithm is fitting around 80% or doing things around 80% correctly. Right? Now, if you look at this chart, this is called the ROC chart, or which actually tells us that how good or bad it is, right? So actually, this curve should be as close as possible to the to uh, this x-axis, right? But here we find they are slightly far off, because as you know that one is 89% correct and the other one is 73% correct. So, and we tried out with 3 different algorithms, bagging method, where we actually collate number of methods together. The naive Bayes is a Bayesian technique where you try to figure out the probability of whether it belongs to class A or class B. And we did a decision tree algorithm, which I just showed you just now in the previous slide. So we find that, yeah, this is around 89%, and this is around 73%. And some of the algorithm, like in this case, we find that the blue one, which is the bagger, is doing better. Whereas in this case, the red one, that is the cart algorithm, is doing better because it actually flattens out as you move towards the x-axis, and that's how it goes flattening out, right? So what we did is that, yes, we find that we could learn substantial 80% in one case, or overall we can say around 80% from this data set, that what type of scheduling is being done. And given a new record, the machine could tell us that whether it should, which one, that is region 1 in international or region 2 in international, where this session should be aimed at, if it is getting originated from a particular department in SGPGI, and if the type of session is tele-CGR, general, or it is a follow-up session. So we could actually get an automated way of doing it. Now comes to the national part. Here also we could manage to learn from the data, and we could get similar outcomes coming up. So like for example, if you talk about the fact that, like I think I'll show you the, yeah. So let's talk about this clinical immunology, right? So if you talk about an endocrinological surgery, right? So if you talk about endocrine surgery, so what we figure out is that it is generally some of them were general and some of them were follow-up sessions, and the machine could actually learn those sessions correctly, right? So that is what we could figure out from there. Then we also did a performance analysis of this data. So what we found is that the eastern region was being most correctly being interpreted, whereas region 2 had a couple of issues here. This was not being picked up correctly. And for region 3 also, we have 50% accuracy. So there is a lot of room for improvement, but the overall accuracy is around 83%. So again, from here, what we find is that the machine can be made to learn the system. So if you look at this diagram here, the decision tree that we saw is doing better than the other algorithms which are there. And in this case, the blue one, that is the bagger, is doing better than the others, right? So in this way, we can actually make the machine learn the schedule. So it's a very simple problem that we're trying to address, though it can be done by a human being. But suppose we had to do it using a machine, we could also do it, and we could get this correct as much as possible in terms of 83% here overall accuracy, and the other one 82% overall accuracy. So that is what we can do. And once we do this, then what happens is that it actually helps us to improve the efficiency of the healthcare delivery system, because now you know exactly where to beam what type of sessions from which department, and that can actually help in reducing the time of the delivery, and also will ensure that the remote located patients are getting the treatments that are happening, and it's going to be a help to or a win-win situation for both the citizens, the doctors, and society at large is going to benefit out of it. Right? So that is what I wanted to share out of it. A very simple problem that we are trying to do, where we are trying to get the machine learn the overall schedule of the SGPGI telemedicine session, and then trying to help in creating better automated schedules for the unit. Right? That's what we are trying to do.